Okay, let's finish up this unit with a few problems involving rational equations and functions. First one looks like this. This one is not to do with graphing, not to do transformations, nothing that we've been doing so far. Now simply just looking at the algebra of how to deal with an equation that has a rational part to it. So we have an equation that has two rational fractions and it's equal to -2. So how do we solve this? Okay, it says use the least common denominator. That's kind of a hint at how to progress here. One easy way to solve equations is to get rid of all the fractions, right? To get rid of the denominators. So to get rid of this denominator, we can multiply by 2 over x. To get rid of this one, we can multiply by x plus 1. So if we want to get rid of both of those at once, we can multiply this entire side of the equation by both of these. So we can begin by doing this. We can say, let's multiply this fraction by both of those. Both of these denominators. Let's multiply this fraction by both of those denominators because we're saying we're multiplying this entire side by both, so therefore each portion has to be multiplied by both. Okay, and then if we're doing that multiplication on this side of the equation, we have to do it on this side of the equation as well. So the -2 also has to be multiplied by both parts. So please continue from there. See if you can solve for x. Okay, let's check our work then. So there, if we multiply the first fraction by those two things, the 2x and the 2x can cancel. So essentially we just have 3 times that. In the second fraction, also the x plus 1 cancels with this x plus 1. So we just have 2x times 2x really. And then on this side, everything remains, we're going to multiply. So continuing from there, we have 3 times x plus 1, because that's what happens here. We have 2x times 2x, like we saw here. And on this side, when you multiply that out, you get this here, -4x squared minus 4x. Continuing from there, multiply through here, multiply through here. Notice on both sides we have a -4x squared, so those can be eliminated. And we're left with simply 7x equals -3, because this 4x went to that side and that 3 went to this side. Solving that, we get this answer here. So that's just a problem to test your understanding of solving equations that involve these rational components. Okay, let's look at another one. So here we do have a function now. We have a rational function or reciprocal function, the kind we've been looking at. We know from what we've learned so far that this has, well, let me ask you, what would be the vertical asymptote and the horizontal asymptote of this function here? Okay, so I hope you came up with those. Remember vertical, we always take the denominator, set it equal to 0 and solve. So that would be 2/3. And for horizontal asymptote, when we have this form, we just look at the coefficients, the numbers in front of x. So it's a 1 here and a 3 here. So our horizontal asymptote would be 1/3. Okay, but this question asks you to find the inverse of this function. So try that now. Try to find the inverse function. And now check your work. So we can begin by swapping the x and y. So both of those x's become y. And this here, which would have been y here, is now an x. Multiply by 3y minus 2 here. Multiply through right here. Then get all the y's on one side. So this y goes over there, but this 2x goes over there. And that's what we have here. From there, you can factor out the y and then divide by 3x minus 1 here to get this new function. So that is our inverse of this one here. I think we've seen something like that before, but I think it's important to come back to this frequently because it's a little bit of a tougher algebraic process here. Hope you're able to figure it out. Okay, and I have one last problem for you. It's a word problem. So we should be able to always look at everything we learn and think of it in some kind of context. So one common application of using rational functions is to think of things calculated as averages. And we'll see that in this problem here. So the problem says Chas and Dev are planning to print their sports team logo on baseball caps and then to sell the caps. So they're making baseball caps and selling them. They have to hire a printing machine. Okay, so they need a machine that's going to do the printing of the logos, which costs $500. Okay, so hire means they're going to rent this machine and do this themselves. So $500 to rent the machine, and it will cost them an additional $5 for every cap that is to be bought and printed. So they're going to pay some kind of price, $5 for getting the cap and then doing the printing for that cap. So 500 is a set cost, the machine, and then 5 for every hat they make. So what would be your equation for that? But look at what A says. It's a little bit different than that. Let's take a look. It says develop a model which links the number of caps they produce with the average cost per cap. So now we're looking not for what is the cost, we're looking for the average cost. And think about it this way. To find an average, we do like this. We have an average cost per cap would be the total cost divided by the number of caps. For example, if it cost you 100 and you made 10 hats, you would do 100 divided by 10 and you'd find out, okay, it costs $10 per cap. So that's kind of what we're doing here. So what would that equation look like? Let's see if you can come up with it. Okay, so here's our cost per cap equation. We have our cost per cap, Y, is the $500 for the machine plus $5 for every cap you make, and we don't know how many caps, that's the variable. So this is the total cost here, 500 plus 5x number of caps. And then to find the average, we're going to divide by the number of caps you make, right? Because this is the total cost, and then you divide by number of caps to get the total cost per cap. Okay, so that's our average. And notice when you do an average like that, you end up with a rational function. That's why rationals are often used to represent things that are averages like this. Okay, so there's our function. Now it says use your GDC to determine how many caps must be printed and sold if they are to sell caps at $7. So they're going to sell these caps at $7 each, and they want to break even. So they don't want to make money on this. This is for a sports team. They just want to break even. So how many caps will they have to make to sell them for 7 and break even? And we talked about break even in the last unit. So break even, first of all, you need the revenue per cap. Okay, so the revenue per cap is 7. That equation for that will be y equals 7. We know that the revenue is 7. So don't think you have to put 7x here. We're not looking for total revenue. We're looking for revenue per cap. So it'd be like 7x divided by x, which is just 7. Okay, so those are revenue per cap. And now we're thinking, well, we want break even. And you may remember that break even is when costs and revenue are equal, right? So here's cost per cap, and here's revenue per cap, 7. You set them equal, and if you can solve that, then you have your answer. You have your break even point. So we looked at that one way, was graphing it. So try graphing those and finding the break even point. So make sure you set the windows correct, and here's this graph shows you kind of maybe a hint on how to set the windows. But here we have our average cost per cap, and we have our revenue per cap, and they meet right here at this point. So what is that answer? What is our revenue? What is our break even point? So if you found that solution, it is 250 and 7. So at $7 per cap, or if $7 are being our price, we need to sell 250 caps. 250 caps to get the break-even point. All right, good applied problem. Be ready to try some more of those in the practice assignment. You are ready for the practice assignment now. Give it a try.